Hello everybody, welcome to Mr. Pass's Math 8 Module 3 test review. So I'm hoping that a lot of you will be able to raise your scores when we retake the test on Wednesday. And I wanted to give you a head start with this YouTube video. So before we do the actual test review, which I'm using new software here, I'm going to go to, and I have the 3 pages plus that. Now, before I go to that, I want to do some review just like I did on the board the other day. So I'm going to click this little shape thing. It's a new software for me, so let's see how it goes. And I told you about this and did it on the board. Hey, that was a decent triangle, but that's better. Okay. And we're going to use our friend, your new friend that you may have never used before, which I call Dorito Man. Now, Dorito Man is, as I told you in class, what you can use for division and multiplication. You can use D for division. Let me make this, okay. Whoopsies. D for division. Okay, for multiplication. So you do not use this when you're using addition and subtraction. I'm going to talk about that in a second. Now, of course, if you think that you are doing great with your positives, negatives, and you don't need any help with that, skip ahead to I can do this. Sorry. Okay, there we go. So if you're amazing with your positives and negatives, then fantastic. You don't need this. However, it's really, really, really helpful for so many of my students because you actually have something you can use, something tangible, something you can draw, not just something like a rule you're memorizing. I feel like if it was me, memorizing a rule is just the worst way for me to try to remember something. 2 negatives make a positive, but 2 negatives only make a positive when you're multiplying, dividing. So if you get a little confused, you can think about Dorito Man. So you basically just draw one on the top of your paper, and it's going to look different than that because I got this weird ink thing going on with mine, with my iPad here. But you're going to have a little pencil. Oh, wait. I got a pencil. Pencil. Oh, wow. That's a little thick, isn't it? Oh, my goodness. Wow. That is something else, isn't it? But you're going to have a little Dorito Man on the corner of your paper, and you can use your finger to cover up whatever sign. So, for instance, if there's 2 positives, excuse me, I just misspoke. 2 negatives, you're going to make that answer a positive. And you know that if it's division or multiplication, you can use Dorito Man for that. For instance, I'm going to be using it through this whole video. So 7, oh goodness gracious, 7 times negative 5. Okay, well we have a positive negative. You just cover that up with your finger. And you can see after you cover that up, the only thing that's left is that negative. Oh, there we go. So negative is your answer. If we have negative 3 divided by, well, we're not going to divide, negative 30 divided by negative 3. Then we got 2 negatives. Cover that up with your finger. And you only have a positive left. So the answer is positive. Okay, that's how that works. Again, you don't have to use it unless you think it'll help you, but it's helped so many of my students. It gives you a way to just be really careful with your negatives. And I want you to be really careful with your negatives, not miss anything like that. Now, I always teach division and multiplication first for one reason. The reason I teach division and multiplication before I teach addition and subtraction is because of what I call double signs. So I don't know how many double signs we're going to have in this assignment, but I figure I'd talk about it anyway. So if I'm doing 4 minus -8, these two signs in a row I would call double signs right here. And if you have two signs in a row, well, what do we do with them? Well, it can be confusing. So anytime you see two signs that don't have a number in between, we use Dorito Man. Because that's actually what's happening in the math anyway. And you turn those into a single. So, two negatives, cover up with your finger, makes a positive. Okay, so we know 4, these turned into a positive. Oh, it's just 4 plus 8. So that's how I do it. Other teachers do it different ways. For instance, if I have 4 plus -8. So again, I see a double sign. Now, by the way, you don't have to have a parenthesis. It doesn't matter. But if you have two signs without a number in between, that's ooh, wrong button. Okay. I'm doing okay for new software. It's working. I figured out this is the only app of the top 3 I tried that actually will make the ink look cool, because I have a Targus pen. I don't have an Apple pen. So anyway, I'm excited about that. So positive and negative. Here we go. Whoopsies. Positive, negative, cover them up. It makes a negative. So I said, oh, that's just a negative. 4, -8. Now, when we have, so another thing I want to talk about is how do we know if it's multiplication, division, or addition, subtraction? Well, the first day that I teach, why aren't you working? I'm trying to get the eraser, and it's not letting me get the eraser. Eraser, there we go. Oh, I know why, because my pen turned off. Okay. So how do we know if it's multiplication, division? Well, this is really important. So let's see. Let me use green. So if you see 4 parentheses 5, that's multiplication. As a matter of fact, you know what I'm going to do? I'm going to move this down, and I'm going to list the different ways that multiplication can be written. Excuse me, I'm trying to find these things because this is a new program to me. So how does multiplication look? How does multiplication look? It looks like this. It looks like that. Or, I should go green. Go green. Go Sierra Vista green. Okay, 4. Oops. All right, 4, 5. Okay, 2 in parentheses. That also means multiplication. Of course, you could have 4 times 5 with a dot. Of course, you could have 4 times 5 with a little x. We don't see the times that much once we get past 7th grade. Anyway, so those are all multiplication, and that's very, very important. The only time, so not every time you have parentheses is multiplication because of double signs. So if you see 2 signs, that is not multiplication. That's a double sign turns into addition, subtraction. So you kind of have to just learn that language and memorize it. There's no way around that. It's like, what is an A? What does it sound like? Well, when you first learn an A, a B, a C, you know, it looks like a strange shape, and we can't explain why, but it's the language. So the language of math is this. Multiplication looks like that, but if it's there, even though there's parentheses, it's not multiplication. All right. Now, what about addition, subtraction? Well, addition, subtraction, I use the same thing you've learned, which is the scoreboard. I think the scoreboard is the best way to do it. So 7 minus 10. All right. Now you can say the word minus, but I always try to think of it as a negative, not a minus. Oh, by the way, I can put this super duper thing here. Watch this. No, oh, I got to do a little straighter. No. I could have done that, but it kind of looks better with handwriting, doesn't it? Oh, well, anyway, fancy toys are not always better. Okay. Sorry about that. So 7, negative 10. Well, some people say which was better, positives or negatives. I just like to say good guys versus bad guys. It's just a way to think of it more as a game. with teams, because the more we think of it as an actual game, the better it's going to be for you conceptually. So, whoops. What happened there? I don't know. My finger hit it or something. Hey, stop that. Okay, I'm having trouble here. Undo, undo, undo. It's not undoing. Whoa, search. Whoa. Stop that. Oh my goodness. So sorry. I'm glitching. Okay, good guys versus bad guys. And this isn't a big deal, but it just helps me conceptualize it. So, first number is positive because there's no sign. Good guy scored 10. Bad guy scored... I just said that. I'm sorry. Good guy scores 7. Bad guy scored 10. So, who wins the game? Bad guys. I always like to circle it because that makes sure you're gonna not forget, hopefully, to put that negative in your answer. So I had a student who did this once, and it helped a lot. Wrote wins, okay, or won, either way. So we know that they won. How many points did they win by? All right. So bad guys win by 3. So you're going to always ask yourself those questions. Who won? It's just regular questions you would ask in a game. How many points did they win by, right? How many points did they win by? I'm going to move this. There we go. Hey, it worked. Look at that. This is a great program. Good notes. Fantastic. I really like it. I'm going to just delete this so I have enough room. Okay. Okay, how many points? Oh, that's bad. There we go. How many points did they win by? I better undo that for that mistake there. Okay, much better. All right, how many? I can't shrink it. That's the only thing I wish I could. How many points did they win by? Whoopsie daisies. Did they win by? How many points did they win by? Right? That's pretty much it. Who won and how many points did they win by? And then you want to circle the sign, right? Good guys or bad guys. And even, maybe, it's up to you. You can write W-O-N or W-I-N. Won or win, doesn't matter. They win, they won. Okay. And circle a sign and then subtract. Subtract final scores. Well, actually, excuse me. In order to find out how many points they win by, you need to add the scores together. So let me put that first, actually. Add for total scores for each team. Now, the reason I didn't think of that is because we didn't have to do that on this problem, but add for total scores of each team. All right. And then ask who won. How many points did they win by? Circle a sign. Now that is, then you subtract, and sometimes you skip the step of adding, like in our case, this one, or sometimes you skip the step of subtracting, because subtract smaller points from bigger points. Or let's say smaller from bigger scores. There you go. Okay, cool. That's it. All right, so that is all of our review for integers. And I just want to make sure I reviewed that because you have to know it. You have to know it. If you don't know your integers, you're going to have trouble. All right, now for our algebra. Woo, algebra! So I'm going to make a line down the middle. I think a good color would be maybe a purple or something. All right, this is a good use of line. Yay! All right, see, I always like to make that line down the middle. It's always a good idea. You don't have to, but I think it's a good idea. Now, I want to get rid of this. And my goal is to get x equals. Some people call it isolate the variable. That's a fancy word. The only thing you have to really think about is, I want to find out what x equals. So how do I find out what x equals? I get rid of everything else. So I'm going to it's going to be easier if I get rid of 0.5. First, you could divide first, but then you'd have to be really careful to divide every single term by 0.3. So it's going to be easier on this problem to do 0.5 first. Now, there are a lot of students in here that were in my class last year. So if you're in my class, you might remember superstar, co-star, and extra. An easy way to see that we get rid of the extra first. But that's not necessary. Okay. So 5 minus 5 is 0. 1 plus 5 is 1.5. And then we don't forget we had this 0.3x. We didn't do anything to it. 0.3x. All right. Now we've got to divide to the opposite. Divide by 0.3. Divide by 0.3. How many 0.3s are in 1.5? There are 5. Okay? Okay. That's it. Now, we can take the extra time, if we have time on our test, to substitute our answer. Some people would say plug in, but the real math word is substitute. So I'm going to take the time to do it right now. You might not want to on your test, or you might. So let's see. What does substitute mean? That means I take this, not eraser, no. Highlighter. I don't have any, I have a choice. Let me do blue. So I'm going to take this, and I'm going to put it in here to substitute for the original problem where that x is. So here I go. I'm going to go 0.3x minus 0.5 equals 1. Okay, well, what do we think x is? We think it's 5. 0.3 times 5. Again, we talked about that's how multiplication looks when we get to algebra or 8th grade. All right, well, what's 0.3 times 5? Well, 0.3 times 5 is 1.5. We add a whole bunch of 0.3s together 5 times, we'll get 1.5. And minus 0.5, oh yeah, that is 1. We take away 1.5, take away a half, it's 1. Hey, we did it. And then I put a big happy face. So you can do that on these kinds of tests and be sure that you have the right answer if you substitute. Okay, 2 ways to do this problem. Well, you can distribute first. You could do that. 2/3 times 6, 2/3 times 9. Now, I could do that in my head, but then again, I'm a math teacher. So why don't we do that? Do we have room over there? Not really. All right, let's do 2/3 times 6. And you could multiply, cross, and reduce later, but if it was me, I would reduce now. Divide those both by 3. How many 3's in 3? How many 3's in 6? Cool. So now we've got smaller numbers to multiply. 2 times 2, we multiply across, right? 2 times 2 equals 4. 3 times 1 equals 3. Oops, 1 times 1 equals 3. I hate when that happens. Sometimes students make that mistake too. That 3 is gone. Okay, so the answer is 4. Okay, so 2/3 times 6 is 4x. And then 2/3 times 9, you can do that same process. And now it's 6/1. I went through that quickly, but you can rewind the video if you want. All right, 4x plus 6 equals... Oops, I didn't make my line. Excuse me. Let me make my purple line. Oops. Let's make a better line. Almost. That's good enough. All right. Okay. All right. Now again, for my old students, you could think superstar, co-star, extra. New people can too if you really want to. It's not necessary. Superstar is always the variable we're trying to find. Co-star's next to it, and extra's over there. Well, we always have to get rid of the extra first. and you do whatever you do on one side of the equal sign, you do on the other side. Do and do. Do here, do there. Sorry, I need more room, so I needed to delete those guys. 6 minus 6 is 0. That's why it's disappeared. Don't do that. Okay. This disappearing feature is kind of nice, but I didn't want it to. 4x equals 2. Well, we need to subtract, and we get 20. All right. Divide by 4 on both sides, and we get x equals 5. All right. Well, I want to substitute. I don't know about you. 5. Substitute in where that x is in the original problem. And we see if it makes a true statement. Well, we're going to find out in a second. Let's see. Okay. So 2/3 times the quantity 6. Oh, wait a second. We need to substitute in. This time I'm just going to write it in instead of waiting another step. So 6 times 5 plus 9. All right, we have to do what's inside the parentheses first. Ooh, squeezing it over there. 2/3, and then what's first in the inside parentheses is 30. 6 times 5, so you said 6 times 5, 6 times 5. Okay, 2/3 times 39. Oh, I just paused the recording and said, what did I do wrong? Well, I caught my markers kind of hard to read there. So I wrote 36 instead of 26. So I didn't do anything wrong. It's called a copy error. I copied. Don't you hate when that happens? Okay. All right, 2/3 times 39. Well, that should be 26. Let's find out if it is. I think it is. All right, we can cross cancel or cross divide, find factors. 3 goes into 3 once, 3 goes into 39 13 times. So 2 times 13 in the numerator. Hey, it worked. I get a big happy face. Let's use pink. Happy face. All right. So checking your answer is a really good idea. I have students do it with these longer problems. It might take a little longer, but I still think it's worth it. That's my opinion. Let's see if I can do a line. Hey, I did it. All right. Now, when we get to longer problems like this, you have on your test this. So you don't even have to memorize it. I would talk about memorizing techniques, but you don't have to memorize it because it's on your test. So distribute first, combine like terms next, put the variable over. I usually did from the left to right, but it doesn't matter. Okay, now isolate, add, subtract, multiply. Okay, and this is supercircle extra to do add first. All right, now by the way, this is, I'm gonna do this. We can tell on some of these what the operation is gonna be. So when we distribute, that is always gonna be. So that means use Dorito Man or do your multiplication rules really carefully. Don't forget that. Combine like terms. Okay, combine like terms is always add, subtract. So make sure you're using your add, subtract rules. So if I were you, when I got my test, I would do exactly what I'm doing right now. I would write this down so that you remember this. Because if you remember this, it's going to make your test way easier. So add, subtract. That's good guys, bad guys. And you want to watch out for double signs. I don't know if there's going to be double signs. I'm just putting it here just in case. Double signs, question mark. Okay, letters to one side. That means you've got an X on both sides. So, let's see if I have... Okay, so for instance, number 8. 8x minus 7 equals negative 2x. Oopsies. Negative 2x minus 17. Wow, I had to squeeze that in. So you have... man, that is really squeezed in there, isn't it? That's okay. All right, we have a variable on both sides. Do we have any distributive to do? Nope. Do we have any combine like terms to do? Nope. We can't combine this x and this number, right? All right. So we don't need the first two steps, but we need to bring a letter to one side. So I always bring it over to the left, but you don't have to. I always throw it over the fence. Like if there's something you didn't like, or your neighbor put something really horrible in your yard and you say, get out of there. You throw it over the fence. Throw it over the fence and change the sign. Again, I do that in a lesson, usually when I'm teaching this. But that's okay, doesn't matter. So we add 2x on both sides. Now again, this is, what is it? Add, subtract, or multiply, divide? It's add, subtract. Every time. So this is also add, subtract. And you don't want to mess up your signs. No. Don't do that. I hate that. You know everything and then you messed up your signs. No fun. All right, then add or subtract. Of course, we know that's add or subtract. Good guys, bad guys is what I call it. Good guys versus bad guys. And then multiply or divide, Dorito Man. Usually divide. Oh, he looks unhappy. No, we don't want any of that. Nyeh, much better. All right, so again, Dorito Man. Let's see. Let's put a highlighter in here. Did my thing die again? What's going on? My pen there it goes. My pen turns off every once in a while. I don't get it. It's such a nice pen. 1, Dorito Man. 2, good guys, bad guys. 3, good guys, bad guys. 4 good guys, bad guys. 5, Dorito Man. And again, you're going to skip some steps on some of these. So for instance, again, number 8 on our test, you don't have to do the first 2 steps. All right. Let's move on to number 3. So we need to go in order. Number 1, distribute. Yep. Definitely have to distribute. So I'm going to distribute. There's 1. Oops. Why can't I make a nice arrow? That's better. That's not better. All right. And remember, as we talked about, and you can write on, not a cheat sheet, but actually it's a very good, you can write out right away the things you don't want to forget. Write them on your test. Boom. And, of course you're allowed to do that. There's nothing wrong with it. But you'll have it there. Oh, I just need to remember this. All right. Study skills. Yay! All right, so 8 times x is 8x. We're multiplying, so I'm going to put my Dorito Man here. Positive 8 times negative 5. Positive 8 times negative 5. Okay, positive times negative. I'm going to cover up this positive and negative. And there's a negative left over. Bonk. Again, you have a Dorito Man on the top of your paper. Always use it. Dun, dun, dun. Okay, and I know my sign's going to be right. I know it because I used a tool. This isn't going to work. Haha. I was a little too close. Okay. These are all positives, so we don't need to worry about negatives. Yay, no negatives. All right. Do we have to combine like terms? Indeed we do, just once for those guys. 8 minus 3. Now you could just do 8 minus 3, but I'm going to be really careful. You really want to be careful on math. They say in the state standards, attend to precision. What that means in fancy words is be careful. Work really carefully. Good guys win by 8. Excuse me, not win. Good guys score 8. Bad guys score 8. Score 3, right? Good guys, bad guys. And who wins on that? Well, I think good guys win by 3. So it's negative 40 plus, let me get a better negative than that, excuse me. Negative 40 plus, good guys win, right? 5x equals 21 plus 9x. Now we need to get the variable on the same sign. So I'm going to take this 9x. I don't know what my neighbor put it in my yard. I said, get out of my yard. That is not okay. Get out of my yard, man. Get out. And when you throw it over the fence, you change the sign. Or just think of subtracting 9x on both sides. Again, it doesn't matter. But here, again, that's good guys, bad guys. So there's a lot of integers in these. That's why I went over it before. So that is positive 5, negative 9. Good guys score 5, bad guys score 9. Bad guys win. Oh, no. I don't want bad guys to win. But they won. Here we go. Negative 40. Negative 40. Bad guys win. 21. This 9x is gone. Why is that 9x gone? Because 9 minus 9 or negative 9 plus 9 is 0. All right, so now we're going to get rid of the extra. Again, the way I do it, not so important, but you can do it that way too if you want. What is that? No, I don't want a ruler. Okay. Oh, come on. There you go. Superstar, co-star, extra. Let's get rid of the extra first. Plus 40 on both sides. That will make that 0. Don't do that. Okay, negative 4x equals... Oh, I made a boo-boo here. No, I made a mistake. I'm sorry. 21. The 2x was gone. 21 was still there. Some of you going in this video is like, what is he doing? Well, at least I caught my mistake. Or did I? I can't believe I did that. Okay, yes, I found an earlier mistake. It's 24, not 21. How did I do that? I don't know. But I did. All right, not perfect, so sorry. 2 mistakes. Ay. And I can't really rewind this video that I know of. Anyway, so I'm going to, so sorry about that. Divide by negative 4. And I get negative 16. That's our answer. Now, how do we check if we made a mistake? Well, I knew I made a mistake because it wasn't coming out to the right answer. It wasn't coming out to an even number. It was coming out to a fraction. And we're probably not going to have that. But besides that, I got my answer. Sometimes you get a negative 16 when it's supposed to be a positive 16. Well, we should check our answer. So I'm going to go back up here. And I'm going to use a different color. So 8, gosh, this is going to be so squeezed in here. You know what? I'm going to move this over. It's going to be way too squeezed. Squeeze. This is going to go over there, which is not good for that. But, oh, well, we've already used it. So 8 times the quantity. Well, what did we think? It was negative 16. Oops, excuse me. Negative 16 again. Equals 3 times 8 plus 3 times negative 16. Okay, cool. So that's our whole problem. What did we do? We took... Now, I'm slowing down to explain to you what I'm doing. But substituting doesn't take that much time if you do it quickly. That's what I did. I put the negative 16 in there where all the x's were. So this is good guys, bad guys. 16 bad guys, 5 bad guys, excuse me. That makes a total of 21 bad guys. And don't forget your sign there. Negative times negative, that is multiplication like we talked about on the other page, right? Oh, where'd it go? We talked about here. That's multiplication. You have to know that. So, multiplication, Dorito Man. Well, 2 negatives. Oh, he looks sad. Don't be sad. Don't be sad. Okay, positive 48. 3 times 8 plus... Uh-oh. I'm not going to put plus because that is Dorito Man for a positive. Whoopsie. Careful. Negative and positive makes negative. I think I should take off that erase thing because I just used undo. I'll do it later. Negative 48. I can't pause the recording and go change stuff. The iPad doesn't let me. 8 times negative 21. Oh, man. Another Dorito Man. So much Doritos. So many Doritos, excuse me. And my pen turned off again. Okay. Negative and positive makes a negative. Negative 168, I believe. I hope I did that right. Did in my head. 8 minus 48. Well, that's a good guys, bad guys. You see, there are so many integers in here. And what I mean when integers, I say using negatives. There are so many times in here where you need to be really careful of your negatives. Okay, bad guys win. How many points did the bad guys win by? 40. Okay, let's see if these make the same answer. I don't know. I'll find out. Oh my gosh, another integers. Another good guys, bad guys. Bad guys score 168. Good guys score 48. I'm not going to circle that. Bad guys win. No, bad guys, no. How many points did they win by? Well, we subtract. Let me do it somewhere else. I don't want to do it on the same spot. It gets too cluttered. All right. Let's see. 128. Yep. So, and remember, bad guys won. That's why I do this whole thing there. Negative. Did my pen turn off again? My pen is turning off all the time. I don't know why I charged it. I think I got to get an Apple Pen because it has pressure sensitivity and this thing doesn't. It's kind of nice though. All right, 3 times negative 40 is negative 120. Okay, found my mistake again. Whoopsies. 8. I was rushing. See, you should not rush. 8 minus 8 here is 120. Okay, so we did it right. That does happen sometimes when you're checking your answer. It does. But I still get a happy face because the answer was negative 16. All right, next one. Now this one, how about you know what, I'm going to erase. Sorry, problem to the left. I'm going to do this one quickly so that you can see that checking your answer doesn't have to take a long time. Here we go. I'm going to prove it to you. Okay, first thing I'm going to do is I'm going to make a line. You know, oh, come on, 2 lines, seriously? Ha, that did a good job on my line. Good job, good notes. Okay, let's try to go quickly. So, do we have distributive? No. Do we have combined like terms? Yes. Boom, boom. So, I'm going to do that first. Whoa, I'm still on the line maker. Even though I'm going to go faster, I want to make sure you can read it. Okay, good guys, bad guys. 20 bad guys, 4 good guys. Bonk. Bad guys win by 16. All right, so let's see here. This is going to be one of those silly ones. Okay, it's either infinite solutions or no solutions. I was going to talk about that at the very beginning, but that's okay. We'll talk about it now. So I'm going to get rid of this 16x. And I'm going to add 16x on both sides. Well, we end up with 0 on both sides. So we end up with 32 equals 12. So what value of x will make that true? It's actually impossible. It's impossible. You can't make any value of x that will make 32 equal to 12. 32 never equals 12. So the answer here is no solution. So much for checking our answer. So I'm going to give a quick little mini tiny lesson on the infinite solution, no solution situation. So if I have x is equal to x, what values will make that true? For instance, if x is equal to 1, is that true? Totally, right? Is that because then 1 is equal to 1? What if x is equal to a billion? Well, then it's a billion equals a billion. What if x equals 5? So in other words, this is infinite solutions. What if we have x plus 1 equals x plus 1? Well, then let's say x is 1. That means 1 plus 1 equals 1 plus 1. What if x equals 10? 10 plus 1 equals 10 plus 1. All right, so you see how that works. This is infinite solutions because every single possible x will make it true. So you got to think logically here. This is one of those lessons here where if you think about what's actually going on, you're going to be way better off. Now, let's say you have let's say you're solving a problem, you get x plus 1 equals x plus 1. And you're going to get rid of the x. Well, then you add 1x on both sides, and the x is gone. Add 1x, I'll just write x. Well, both x's are disappeared. And we have 1 equals 1. Well, when does 1 equal 1? Always, never, sometimes, always, 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 always. So again, this is still infinite solutions because 1 does always equal 1, no matter what x is. Let's say x equals 25, right? It's still going to be true. All right. So what about no solutions? Well, no solutions comes from this. X equals x plus 1. Now, how can you think of an answer that possibly works for that? What if x equals 4? 4 equals 4 plus 1? Nope, it doesn't. What if I try 0? 0 equals 0 plus 1? Nope. What if I try negative 8? Negative 8 equals negative 8 plus 1? No. So there is no possible solution. It never can work. Ever, 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 ever. Can't work. There's no solution. So you think about what's going on. Now, often, again, so you could stop when you get to something that looks like that. Oh, I can spell. Or if you're getting rid of your x's, your variables, and you get something like we did on our last problem. You get something that says, hey, wait a second. We get 0 equals 1. Well, that's never true. So if you get rid of your variable and it's something true, that's infinite solutions. If you get rid of your variable and it's something false, it's no solution. So that's it for that. I don't know how your teacher taught it to you. Maybe similar, probably similar. But that's the way I explain it. Hopefully that helped. Now, let's go to our special line tool. Oh, that wasn't good. Man, it's so cool how you don't have to be very exact. Okay. My new good notes. Fun. All right, so 6. Okay. So first step is always distribute. Do we have distribute? Yes, we do. Why is that the first step? Because we can't add and outside of these parentheses. These parentheses would cause a problem mathematically. You have to always follow the laws of math. Come on. No. Okay, I did it. So 6 times x. Well, oh, wait a second. A negative. Boo. You have to be careful with your negatives. So you have, oh my gosh, that looks so angry. I cannot do that. Much better. So positive 6 times negative 3. Cover up the positive and negative. Okay. Again, if you originally thought, that Dorito man's weird, and now you're saying, wait a second, I always have something to use. You know, I can always be super sure that my negatives are right because I'm working carefully through this little thing I can write down instead of memorizing the different rules that can be confused easily. So positive 2 times negative 4. Positive times negative. Dun, dun, dun. I really need to go into those settings and stop that. Okay, I walked away from the screen to get my dog, and she runs away to play, and then it stopped recording. I'm going to see if I can merge those together. I hope so. I got my amazing dog cuddling with me. She's all cute. All right. Uh-oh. I see what's going to happen. We got 6x and 6x. All right. Meow. Meow. All right. This is going to be one of our funny solutions. Now, negative 8 does not equal negative 12. Ever, ever, ever. X is never going to be able to do that. So this is no solutions. All right, let's move on. Do we have distributive? No. Do we have combined like terms? No. Do we have variables on both sides? Yes. Oh, I forgot to make my line. Meow. Yay. All right. I'm going to add 5x on both sides. Throw that thing over there so we have variables on only one side. Oh, integers again. I said inter, but it's integers. Bad guys score 3, good guys score 5. That means good guys win by 2. So that's positive 2x. You don't have to write the plus. Okay. Again, this is my little trick that you don't need to use, but if you really want to, you can. Superstar is what we're trying to solve for. Co-star is right next to it. And extra's kind of far away. So we want to get rid of the extra first. 5 minus 5 is 0. That's how we're getting rid of it. Oh, I took away that erase thing. That's great. Okay, again, you have to be really careful with your negatives. 7, how often as math teachers we see students do everything right and then make mistakes on the negatives and we're like, oh man, but they knew what they were doing. No fair. Well, if bad guys scored 7 and 5, that means the score is 12-0. Bad guys. 12. I forgot to write that x there. Okay, divide by 2 on both sides. And x is equal to Dorito Man for division. Negative and positive. Okay, -6. Yay! Now, that's not one of our special solutions. And what we want to do is check our answer. So let's do it. So I'm going to do, not that color. Okay, let's do that. 3. Oh, -3. Don't forget the negative. That would have messed up my checking, wouldn't it have? 3x plus 5. Oh, instead of the x, though, I'm going to write the number. 3 times -6 plus 5. Oh, I'm running out of space here. Let's move this over there. Equals -5 times -6. We need to move it over even more. Oopsies. -7. All right. So negative times negative. 18 plus 5 equals 30 minus 7. Is that true? 23 equals 23. Yeah! Yay! Okay. Check my answer. By the way, I had a couple students check every answer last year on their test, and it was so great because they knew their answers were right. It really helps. Remember, distributed is first, so you can look at your paper on your test where your teacher wrote it for you. That's a big help. All right, again, I like to use superstar, co-star, extra. The superstar is the variable that we're trying to find. Co-star is right next to it. So we want to get rid of the extra first. Oh, I did not make my line, did I? No, I did not. And now I realize I didn't line it up very well, did I? Well, let's fix that because it's digital. Yay! So -12 on both sides is, this becomes 0. 42. Oh, I forgot good guys, bad guys, but it was just subtraction. But we could do it just in case. Good guys score 54, bad guys score 12, so good guys win. So I did it right. Divide by -6, divide by -6. Oh boy, we got some negatives here. We've got some negatives here. So a positive divided by a negative makes a negative. -7. All right, now is my answer right? Well, I think I should check it. I'm going to check it. See how long it takes to check it. -3 times 2 times -7 minus 4 equals 54. All right, the innermost parentheses have to go first. -3, -14. Okay, Dorito Man, but I'm trying to show you how fast I can do it. 4. All right, -3. This is, I mean, I'm going to use good guys, bad guys for this because I definitely don't want to mess up those negatives. Okay, that makes 18. Bad guys win. Three times -18. Okay, negative times a negative makes a positive. And then we get that. 54, I believe. Yep. It works. So see, checking your answer doesn't take that long. It takes a little bit of time. But if you time that, I don't know, a minute. So you have a minute. 2 minutes at the most. All right. Here we go. Let me move that over because, well, I'm just going to erase it because we don't want that to distract us. All right. Line. Gotta love the line. Do we have distributive? No. Do we have combined like terms? No. So, I mean, if they were there, we'd do them, but they're not there, so we don't need to worry about it. Our third step is to bring your variable to the other side. So I'm going to, oh no, get rid of that shape tool. Okay, I'm going to add 2x so it makes 0. Oh man, my dog is so great. She's so cool. I don't know if any of you dog people, but I love dogs. I like cats too, but dogs are the best, in my opinion. Well, this dog is the best. Superscripts are extra. Add 7 on both sides. Uh-oh, we're going to have negatives here. I would do it here, but I don't want to. I want to use that to check my work. So I'm going to do it here, even though it's a little more clutter. Bad guys score 17, good guys score 7. Bad guys win by 10. All right, divide by 10, divide by 10. I get x equals, uh-oh, negatives again. See, I'm telling you, if you're in the habit of using one of those, and you don't have to draw it every time, I do when I'm doing digital stuff here. But again, you just put that Dorito man on the top of your paper. Oh, let's make him a little bit happier. And then you cover up with your finger. You don't need to draw it every time, but it shouldn't take you that long. And you really make sure you don't mess up your negatives. So easy to do that. I do not want you to do that. I want you all to get good grades. 8 times -1. What am I doing? I'm checking my answer. Oh man, I'm going to run out of room here. Let me move this. I hate that. Okay. -2 times -1. I'm still running out of room. No. Okay, this is getting a little annoying. Come on, -17. All right. So 8 times -1 is Dorito Man. It means we got a negative. So -8, -7 equals Dorito Man here. 2 negatives make a positive. +2, -17. All right, we need to do our guys for both of those. Bad guys score 8, bad guys score 7. That's -15. And I hope it comes out the same. It looks like it's going to. 17 bad guys, 2 good guys. Hey, bad guys win by 15. Hey, we did it. Yes. Okay, I checked my answer. Okay. All right, moving on, moving on. Yeah. Do we have distributive? Yep. Whoa, that's not the right thing. It's supposed to be a pencil, but I don't know if I'm zoomed in too far or what. Okay, distribute first. 8x. Uh-oh, we've got a negative. That was not working out right. Dorito Man. So negative and a positive. 8 times 2. That makes -16. Once more, I keep saying this. You really have to be careful with your negatives. If you're not careful with your negatives, it's going to be no good because you'll keep, making mistakes on your negatives. And we don't want that. You'll keep getting the wrong answers, I should say. Do we have combined like terms? Yes, just once here. 8 plus 6. Hey, we don't need good guys, bad guys. Yay. Plus 14x. 22 minus 5x. Okay, so we want to get rid of this so we have variables on only one side. Throw it over the fence and change the sign, or just make it 0 with plus 5x. That becomes 0. All right, negative 16 plus, oh man, we didn't need good guys, bad guys again. That's awesome. Okay, again. I'm going to do my superstar, co-star, extra, which you don't have to, but I like to. Superstar, co-star. Okay, I need to get rid of the extra first. Let's do that. Plus 16 on both sides. OMG, we do not need any good guys, bad guys again, because it's just adding. Man, this problem is awesome. 38 divided by 19. That's going to be 2, I believe. Why don't I have room to check? Because the problem went all the way to the right side. So, sorry, I don't have a way to shrink it on this software, even though the software is great. But, oh well, I'm going to have to erase. I went back. When I erased it all, I forgot I got the answer that I had was incorrect. OMG. Oh, goodness gracious. All right, well, let's go back. 2. I hope it was. I'm going to go back and look at the video, but I'm pretty sure I had it right. I just forgot when I went back. So now let's make sure I was doing it right for substituting. I just, somehow my mind went to the wrong number. All right. Okay, 8 times 0 plus 12. That makes it easy because 8 times 0 is 0. 22. We've got negative 5 times 2. Well, negative times a positive. We'll just do a new one. Makes negative. All right, 22 minus 10 makes 12. So, hey, this definitely worked now that I remembered the right answer from the other time. Oh, buddy. I'm going to go back on the recording. I'm pretty sure I had 2. And then all of a sudden my brain went to negative 1 for some strange reason. I don't know why. All right, let's move on. Deanna and Lulu are playing games at the arcade. Deanna starts with $15. And the machine she's playing costs 75 cents per game. So I'm not going to look at the multiple choices. I like to try to figure it out without the multiple choices. So I know that if I'm making an equation, start with $15 every time I play a game, right? I subtract. Well, it looks like they're using G, so might as well use G. 75 cents per game. Not point 0.75 per game. All right, so if I play 10 games, I got to multiply that 75 cents. All right. Lulu starts with 13, and her machine costs 50 cents. Now, you want to find out how many games they will have exactly the same. So when will these equal each other? That's what it's saying. How many games the two friends will have to play to have the same amount? That wasn't a highlighter. So how many G's makes the same amount? That's a little tricky problem, I think. I don't know. When will they be equal? So the other person was $13 minus 50 cents per game. Now, they didn't ask us to solve it. We could, though. So choose the correct expressions, and it says plural, so let's see. The first one. Hey, the first one's right. I like the first one. It looks exactly like what I wrote. But is there another one? Because it does say expressions. Well, we'll find out. 15G, no, it's not 15 times the amount of game. Definitely not. So I'm going to say no. Not for that one. Okay, how about this one? 15 plus 50 games? Okay. All right, well, that's really tricky. So I think that expression is correct as well, but I don't know who would ever think of it that way, but it's correct. 15. Did my pen turn off? Yes, it did. 15. Now, we're going to have to add 0.5 G, and we're going to have to add 0.75 G on each side. So when we do that, what do we end up with? Well, we end up with 15 plus 5.5 G and 13 plus 0.75 G. Whoa. That is really bizarre. I mean, I wouldn't write that, but it's correct. I would not write that, but it's correct. All right, 15 plus, no, because she's losing money when she spends it, so it's not plus. So that is wrong. And then this one, 15G plus 75. No. Because again, Lulu's 15 is not adding. Lulu's 15 is subtracting. And it's not 15 times the number of games. Definitely not. So that one's not true. So you could choose C also on that one. Did my pen turn off again? It's supposed to be 10 hours of battery life, so I should still be okay. Party supply company charges a setup fee of $35 plus $50 per hour. So that means, again, I'm not looking at the whole problem. I just like to set this up. Sometimes you set things up and it turns out that the problem goes a different direction. But I feel like I want to just turn it into math right away. That's just my process. Excuse me. If your process works better, it's just fine. Okay. Another company charges $55 per hour for the same house. No setup fee. Again, it's per hour. Okay, so solve the equation to find out how many hours in order for the cost to be the same. In order for the cost to be the same. So how many hours, which is the value of H, okay, for the cost to be the same. So that's why I put an equal sign between them. All right, now I usually go right to left, and you can, but you'd end up with 0 on this side, and you'd have an extra step. So I'm going to turn it to the right. Again, doesn't matter really, but it is going to give you an extra step. Minus 50H minus 50H makes that 0, because 50 minus 50 is 0. Divide by 5, divide by 5, 7 equals H. All right, 7 hours should be the same. Now, am I going to check my answer? Yeah, I am definitely going to check my answer. So let me kind of try to erase that. Let's check our answer. But I don't want to check plus, plus, plus. Oh, plus, and that means minus on both sides. Oh, wait, that comes out the same. So therefore, in the very first part, I had to have this. So it does work out correct. Basically, I copied wrong. And there's a plus here, so I don't know why I didn't write a plus. 385 equals 385. See, checking my answer helped me. Okay, but my answer was correct. 7 hours. All right, for each box, fill in a number that will have the final answer of no solution. Well, if it's negative 3x plus 7, that's infinite solutions. So I can write anything else. I can write 0, I could write 7.1, I could write 9, I could write a billion, doesn't matter. But as long as this number is different, then it's no solution. But the 3x has to be the same. Negative 3x has to be the same. For each box, fill in a number that will have infinite. Okay, infinite means it's exactly the same. 9 and 8. Okay, John has correctly worked out the following two problems, but needs a final answer. This is the same thing as No solution in infinite many solutions. Whoopsies. Okay. So let's check it out. Well, 10 equals 7. 10 never equals 7. No solution. And it said he did it correctly, so we don't need to check his steps. 11 equals 11. Well, that's always true. Infinite solutions. We're done. Except we're not done because I'm going to do some more practice. I don't know if I should put this on a separate video. I think I'm just going to leave it on the same video. Why not? Now you have to go through your list. Distributive is first. My hand's starting to hurt though. Oh well. I like doing math, so I'm happy. It won't zoom in anymore? Oh, there you go. It's being funny. I don't know. All right, do we have distributive? We definitely do. So we're going to do distributive. All these problems are going to have a lot of distributive. Oh, man, and we start out, we already have negatives to worry about. 2 negatives make a positive. Positive 35R. Again, negative 5 times negative 4. Well, we just did 2 negatives, but I'm writing out to show you that I really care about being careful about my negatives. I'm going to lead by example here. 2R. 10 times 2, we don't need Dorito Man. All right. Do we have combining like terms? Yes, but only once. Did my pen turn off again? Yeah. Why is it doing that? 35R plus 20. 112R plus 20. All right. This is going to be one of our special ones, huh? Maybe. Let's find out. No, it's not. Oh, it's going to be, that's right. I remember this one. It's kind of a special answer. So we're going to subtract 112R on both sides. Well, 112 wins. How much do they win by? I'm going to have to do my subtraction. Where should I do it? Maybe over here. 112 minus 35, is that right? Yeah. All right, 77. Okay, bad guys win by 77. All right, we're going to subtract 20 on both sides. Negative 77R equals 0. Oh. Well, what number times anything is 0? It's going to be 0. So if I divide by negative 77, we can see the answer is 0. So it's not one of our special solutions, really. It's 0. All right, now I am going to erase this because I'm not going to have enough room to write this out over there. Wish I could leave it, but it's not going to be enough room. All right, so negative 5 times negative 7 times 0, which we know what that is already, but I want to write it all out. Sometimes it's good to be complete. Zero minus 4. 0 plus. All right, that's 0. Okay. And we don't need to worry about this 0, do we? All right, so we don't need to worry about this 0 either. Okay, 2 negatives make a positive. Positive 20 equals positive 20. We did it. All right, we tried 0. 0 worked. Now we are going to have a bunch of, well, 3 different problems that are special solutions. So you're going to have to be aware of it. I should say ready for it. Remember, first, negative times a positive, negative 44n. Again, negative times a negative this time, though. So many negatives to mess up. Well, these are all positive. That's good. Okay, there we go. Do we have combined like terms? Only once, but we need to do that. 49 minus 1. We really don't need this, but I'm going to do it anyway. Good guys win by 48. Okay, we're going to move this 7n over, or just subtract 7n on both sides. Oh, good guys, bad guys again. So many. I'm going to delete one of these, though, so I have more room. Bad guys score 44, bad guys score 7. That means bad guys scored 52. Is that right? That's not right. It's 51. Negative. Bad guys win. So negative 51n plus 99. These became 0. All right. Again, like I've said before, I did forget my line, but I can draw it now if I want. And I can even move everything over if it's going to fit, kind of. Let's see. So that it's all lined up. Yeah, that worked. Superstar, co-star, and extra. Get rid of the extra first. This becomes 0. Okay, we have to be careful of our negatives again. 99 bad guys, 48 good guys. Well, bad guys are definitely going to win. By how much? You know what? I'm going to get a smaller pen. 99 minus 48. 51. And bad guys. Negative 51. Oh, hey, answer's going to be n equals, again, another negatives. Negative makes a positive 1. And that is the right answer. I could check it. Let's see, do I have room? Well, I guess I can. I just want to make sure. I feel like the video is going on long. That's okay. I want to prove to y'all that I do believe in checking your answer. I definitely do. So let's do it. Negative 11, 4 times 1. Equals negative 1 plus 7. 1 plus 7. All right, so what did I do? Let me double check what I did. Whoopsies, wrong button. 1 for n, 1 for n. Yep, that's it. All right, so we don't need to distribute because we have numbers. Don't need to distribute. We just do what's in the parentheses. Negative 11 plus 7, and that's 8. Excuse me. All right, negative 11 times whatever that is. Well, we have to be careful with our negatives. 4 and 9. Negative 5. Bad guys win by 5. And these are all positive, 56. Okay, negative times negative is a positive. Positive 55 equals, hey, 56 minus 1 is 55. We did it. It worked out. Moving on. We're going to distribute. Oh, let's make our line. Distribute. Oh, distribute here too. I'm going to write both of them. Negative 10 times positive n is negative 10n. Negative times positive makes negative 100. Oops, I need to do my distributive here. Somehow that disappeared. Negative times positive again. So negative 8. Up here it's negative times negative. So negative 8. There you go. Do we have combined like terms? Only one place. Oh, we got to be careful with our negatives. 2 and 8 makes bad guy score 10. Got to get rid of this this negative 8n. We need to get it on. So now bad guys and bad guys, but this was for another problem. Let's do this. 10 and 8. 18 bad guys. Negative 18n minus 100 equals, this cancels out. Negative 10. We need to add 100 on both sides. That looks similar. Okay, positive 90. Now, does that work? I think it does, because 18 times 5 is 30. 5 is 7. That's 80. How come it's not 80? 5 times 8 is 40. Oh, I just copied it over here wrong. I had 80. It's 80. Yeah, 40. The 4 is here. It's 80. No. Okay, I was fixing the wrong part. So yes, the answer to the multiplication problem here is 90. And that's what we wanted anyway. So I basically multiplied wrong here. Okay. I made a mistake on my arithmetic. Da-na-na. So we divide by negative 18 on both sides. And we know that 5 times that is 90. So that cancels that out. N equals to positive divided by negative 5. I'll admit it, I'm getting tired of doing these problems right now, so I don't feel like checking it. I'm so sorry, forgive me. Plus, it's getting really hot in this room. But when I pushed pause last time, it turned off. So, all right, let's work on this problem. Da-na-na. Okay, do we have distributive? Definitely. Let me erase this stuff, so it's kind of getting in the way. All right, let's see here. Two distributive on the same side. Well, we can do that. Why not? But M's are kind of, I'll take a lot of space to write. Okay, my equal sign like this. Negative 10 times positive n. That's negative times a positive for both of those multiplication problems, which means we end up with a negative. Okay. Negative times a negative here makes a positive. Again, two negatives make positive. All right. Do we have to combine like terms? Yes. Those two are alike, and these two are alike. All right, let's see. Negative 10m and positive 3m. Okay, be careful with your negatives. Bad guys 10, good guys 3. Bad guys win by 7. Okay, and now we have to do this guy. Negative 90, positive 27. Let's subtract. 8, 3, 6. All right, 63, bad guys win. There you go. We've got variables on both sides now. So, oh yeah, in my brain, I was thinking of this as a number 1. It's not number 1, it's 1m. So we need to combine those. So we're going to do the negative 8 and the positive 1m. We get negative 7m. Much better. I knew there was something bothering me. Now, if we add 7m, on both sides. They're both going to cancel. We're going to get 0 equal to negative 633. No, it doesn't. So this is no solution. Now, if I would have gone through the whole problem with thinking that was a 1 instead of an 1m, then I would have gotten a different answer. And then I would have tried to put it in the problem when I checked it, and I would have found my mistake. But I felt something was wrong anyway. My spidey senses felt like something was wrong. Okay. Math. So much math. Distributive. Distributive. Yay. Those are some terrible arrows. I'm going to fix those. I don't care if I'm tired. I'm still going to do good arrows. All right. Make me a line. Better. Negative 4a. Negative 4 times positive 5. Negative times positive. Negative 20. 18. It's a negative. Positive 2 times negative 3. There we go. Oh, I did have more room. Positive times negative. So we've got negative 6a. All right. Like terms, there's only those two. Oh, wait. No, there's 2 over here. Don't forget. All right, there we go. Negative 4a. Negative 15 equals 18 minus 9. I don't need it, good guys, bad guys, for that because I know it's just subtraction. Okay, now we need to get rid of this. We want to get our variables on one side. Just going to throw that over the fence and change the sign. Or we can just add 6a. Don't forget about your negatives. To be careful. Bad guys 4, good guys 6. So positive 2a. That got canceled out. Okay, for me, I can do my superstar, co-star, extra. And I get rid of the extra first. Hey, I don't need good guys, bad guys. Hooray. Oops, why did I put X? These become 0. 24. 12. Now I can tell from my answer key that I'm right. And I kind of have to start going here very soon. I don't have time to check it. I'm so sorry. I don't have time. But I checked my answer key. All right, let's move on. Distributive. 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 Distribute a negative 1. That means negative 1 times positive 5. Let's make a good Dorito, man. Negative 1 times positive 5 is negative. Negative times negative. Positive 30. Negative 5 times positive n. Negative times a negative. So it's positive 10. Okay, what do we have? We have combining like terms only once. So I'm going to write the problem again. Oh, I didn't draw my line. You know, for years, I never had lines like that. And I saw another teacher do it, and I said, that's a good idea. So I like the lines. But I didn't used to use them, so that's why I forget. All right. Negative 4, positive 10. Good guys win by 6. All right, we need to get rid of this 5n. Uh-oh, I see what's going to happen. I'm going to add 5n on both sides, and it's going to become 0. 0 and 0. And we got 30 equals 6. Uh-oh, 30 equals 6 is not what we want. 30 equals 6 is never true, so this is no solution. And I see on my answer key, it's right. 7. Almost done with all these practice problems. You know, you don't need to erase all of that. Pass. Let me just erase this. Ah! There I am, okay. I'm back. Distribute first. This looks sketchy, doesn't it? No, sketchy. Yeah, 4, 9, it looks very similar, doesn't it? Well, let's see what happens. Negative 4 times positive. Negative 30. Oh, I should make my line. You know what? I should have moved over because I'm going to run out of room there. Let me just start over. Okay, negative times a positive makes a negative. And then again, negative times positive is a negative. M. All right, negative times a positive again. Negative times a positive again. That's a lot. Everything's negative. All right, I'm going to add. See, I was right. I knew it looked funny. So when we add 36m on both sides, they both cancel. It's going to be one of our special solutions. Does negative 6 equal negative 40? No, never. That's it. Okay, number 8. Last one. We need to distribute. Let's use a different color. Actually, let's make it a little cleaner here. That's better. I haven't used blue in a while. Let's use blue. Negative 2x. Oh, don't forget your line. Negative 2x. And then, oh, I think I did it without drawing it. No good. Negative times positive. I went quickly because I saw that 1x. All right, 6 times 1, we don't need Dorito-Man. 6 times x, we don't need Dorito-Man. They're both positive. All right, so let's, do we have any combined like terms? No. So I'm going to get this 6x on the left side. And I'm going to subtract 6x on both sides to do that. That cancels that guy out. All right, well, again, we have to be careful with our negatives. Bad guys score 2, bad guys score 6. That means bad guys beat the other good guys didn't score anything. Not good, man. Okay. What is going on with my 6s? That's better. All right. Superstar is x. Co-star is negative 8. Extras here. So we want to get rid of the extra first. Hey, we're not going to need good guys, bad guys there. Hey, that's fun. 24. Okay, a positive divided by, well, we're going to divide by negative 8 on both sides. What's going on with my pen? Don't worry, I'm going to get it to work. I'm going to maybe draw a little slower. Better. Not perfect, but better. All right, so this cancels this out, but we need to be careful with our negatives. Positive divided by negative. Negative 3. Okay, now I see on my answer key that's correct, but on the test you're not going to have an answer key. And I feel like I've got enough energy to do this. Let's do it. So we're going to check our answer. Negative 2 times the quantity negative 3 plus 9 equals, my pen is, you know what, I'm going to use a smaller pen and see if I can just get this to fit better. I bet you that's going to work. Negative. It's just going to be... Hey, we got a double sign finally. After all this time. So, double sign. What happens to a double sign? We use Dorito Man and turn it into a single sign. That's a terrible Dorito Man. Sorry, Dorito Man. They have those purple Doritos. They're yummy. All right. Negative, positive makes a negative. So, I can rewrite this whole problem, although you probably don't have to. But just to make it neat, I'm going to rewrite it with single sign. And that makes it a lot simpler for me when I do my negatives. All right, inside this parentheses here, we need to be careful with our negatives. -3, +9. Good guys win by 6. Okay, 1 and -3. Bad guys win by 2. All right, now we need to multiply and be careful with our negatives. So many negatives. Same thing. Hey, we did it. -12. Okay, now I wasn't perfect through this whole experience, but I fixed my mistakes, I think, fairly quickly. And that's it. Please study a whole lot. Please study a whole lot. And you will be able to pass. Practice, practice, practice. You'll be able to do really well on that test. And I'll be happy and you'll be happy. And everybody will be happy. And what's over here? Right, my infinite and no solutions. All right. That page looks fun. Let's end on that. See y'all back at school. Bye-bye.